Hey, so we're going to be doing a lab on different types of plate boundaries today. And this is something you can do at home, and hopefully your parents were able to get the materials for you. I'm going to show you how it's done. So I'm going to be using just some instant vanilla pudding to do this. You could use Cool Whip. I've also seen people use icing, so we want something kind of thick. So I'm actually going to make this pudding a little thick. So I'm going to make it, instead of, it calls for 2 cups of milk, I'm going to use a cup, maybe a cup and a half. So I'm going to make it a little thick. So first I'm going to start off by making my pudding. All right, measuring out my milk, putting together my pudding. Now I want it to kind of resemble magma. Okay, this is going to be modeling our magma. I'm going to put a little bit of red food coloring. I'm not sure this red food coloring is going to make it very red. It might make it more pink than anything, but you can just pretend that this is magma as we do this. So I'm going to put a little bit of red food coloring in my milk before I add. Okay. And I'm just going to put some vanilla pudding in here. And we're going to whisk it and set it aside. Okay, let's get started. So I mixed together a cup and a half of milk and some red food coloring. And I'm just going to place on my wax paper here, I'm going to place just a spoonful. All right, and then I'm going to use some graham crackers. And of course, the graham crackers are representing or modeling the crust. And this pudding, it doesn't really look like pudding, but it is, smells like it. This pudding is representing the magma under the crust. So when we put these together, the first one that we're going to model is the first one. Which one was I going to model first? Okay. All right, so the first one that we're going to model is a transform boundary. And in a transform boundary, one piece of crust moves one direction, one moves the other direction. And so you should push them kind of together, and you should see like little crumbs that are created when you slide them along each other. And so you find transform boundaries places where the different crusts are rubbing against each other. And one that you're very familiar with is the edge of California. And so there are a lot of earthquakes along transform boundaries. All right, the next one that we're going to look at is a divergent boundary. Okay, so to model a divergent boundary, let's look at the model here. All right, same one. This time I want you to just kind of push a little bit down and out. So then if it's coming apart, it's diverging, coming apart, you can see that the magma is coming out between it. And so we see this type of transform boundary like at the bottom of the ocean, at where the oceanic plates move apart and the mid-ocean ridges are formed. There are other places too where we see where we see divergent boundaries. Where continental plates move apart, we'll see rift valleys and maybe some volcanoes happening. Okay, the last kind of boundary that we're going to see, plate boundary that we're going to see, is a convergent boundary. And we're going to have to model two different types of convergent boundaries. The first thing I'm going to have you do, if you need to reset your wax paper and redo your, mine still look pretty good. I'm just going to kind of gently put them back together. But what I need you to do, for the first one, we're going to wet the graham cracker. So let me show you what that's going to look like. I'm going to take a little bit of water, and I'm just going to put several drops on the graham crackers and between the graham crackers here to get them good and wet. You might want to wait for just a couple seconds to let that soak in. Okay, so now this is the type of convergent boundary where two plates that are about the same density are coming together. So like maybe two continental crusts that are merging. And so what happens when that happens is if you push them together, mine are still not wet enough. Let's wait. Okay, so I put some more water on. I gave it a little while. So now I'm going to push these together, and we're going to see what happens. All right, so you can see that the graham crackers representing the crust are coming up. So this is like when mountains form. Okay, when their continental crusts are pushing together, pushing up mountains. Okay. Last one. So I'm going to take two new ones because those the mountains got awfully wet. I had to throw them away. Okay, so I'm going to do another, and I've got the same magma, if you will, but I've got new plates. So what I'm going to do with these, one of them is going to go underneath the other one. So sometimes when plates converge at convergent boundaries, one of them has more density. It's more dense than the other one. And so we're going to show that by, I'm going to put water on one of them, and I'm just going to do it by kind of dipping it for a moment. And the other one I'm not going to make wet. So the one I'm not going to make wet, I'm just going to leave right there. And this one is wet. Oh, maybe a little too wet. Anyway, so the one that's wet is probably a little less dense now. It's kind of gotten bigger. So what we're going to show here, as I push them together, one should go under the other one. So you can kind of see the more dense one slides under, and that's a subduction. And so it's a type of convergent plate boundary. Okay, answer your questions on the lab, and I hope you enjoyed it. Now you get to eat some of your pudding or whatever it is you use for magma, and some of your crackers, and enjoy.